Yes, good morning. So today I would like to introduce the basics of the VHDL. Already I said that what is VHDL? It is a one type of HDL. HDL. It is HDL is hardware description language. VHDL means very high speed integrated circuit hardware description language. Actually, this language has 5 constraints in order to develop the program, like entity declaration, architecture body, configuration declaration, package declaration and package body. But out of those, now I am going to introduce 2 constraints. These two are the minimum. These two are the minimum in any program. Okay, these two are the minimum in any HDL program using VHDL. That is entity declaration and architecture body. Now let us see what is the syntax for entity representation and also architecture body, and also in the same session we can see the entity declarations for different digital circuits and also architecture bodies. Coming to entity declaration, so the syntax is, it starts with the word entity. It starts with the word entity followed by name of the entity, then is the first line. The first line of syntax of entity declaration is start with the word entity, then name of the entity is, then port. The port includes different signals. The port includes different signals, their mode and their data type. So many number of ports you can include in the port. It includes various signal names. Signal means a port, input or output port. Okay. Various signal names, their mode represents the direction, that is whether this signal is input to the system or output from the system, and type or data type. So which data type, so each port or each signal can accept. Then finally end with the name of the entity, but name of the entity is the optional one, and each and every statement here enclosed with the semicolon. So this is the syntax for the entity declaration. Okay, start with the word entity, then name of the entity. Name of the entity is user defined name. Any name the user can give, but usually for which digital circuit we are going to write the entity, that name, writing of that name is better. Okay, is the port is different input, port represents different input and outputs and their acceptable data types, and finally end with the entity name. So that is the syntax. Based on this syntax we can know that the entity represents or entity declares or defines inputs and outputs, number of inputs and number of outputs, and their data type. Okay, of course sometimes the initial value for each port also we can mention. Okay, so let us see an example entity for a digital circuit like this. Okay, that is coming to example, let us take half adder. So let us take an half adder. So this is the half adder block diagram. Okay, so for writing the entity for any digital circuit, no need to know the internal logic. Internal logic means whatever the gates it has, what is their connection, the connection in between them. No need of that information. Okay, only how many inputs that digital circuit has, similarly how many outputs that circuit has. That information is enough for writing the entity. Now with this example, how many inputs it has? 2 inputs, right? A, B. And how many outputs it has? 2 outputs. sum and carry. Therefore, with reference to this digital circuit, how can you write the entity? Okay, so as per syntax, it start with the word entity. Start with the word entity, then followed by entity. What is the thing you have to maintain is the name of the entity. Name, that is, I said already, name is user defined name. Any name the user can use. User is, who are the users? Ourselves. Okay, so I am giving the name as half adder. Half adder is, then as per syntax in the second line, port has to be start port. So the port includes different signal names, their modes and data type, right? So here two input ports I have, one is A and another one is B. Both I am declaring in the single line. So A comma B colon, A comma B colon, mode is in. Mode is in because these two are the input to the system. Then standard logic. Standard logic is a predefined data type in the language. It is a data type. Okay, so it represents what type of data the input A and B can accept. Similarly, this digital circuit has two outputs, sum and carry. So I am declaring them as sum carry colon out standard logic. Okay. Since these two signals are the output signals, therefore in place of mode you have to write out. Okay, so the different modes for the signals which declared in the port are in, out, and buffer. There are four modes each signal can allow. In represents those particular signals are input to the system. Out represents they are acts as outputs for that system. In-out means that particular signal can be used as both input and also output. The buffer also having the same scope of the input, but there is a slight difference. In further classes you can observe what it is. Okay, then finally end the entity with and entity name. Okay, and each one ended with the semicolon. Okay, so like that you can write the entity for a given digital circuit. Is it clear, all of you, how to write the entity? Okay, just by knowing the number of inputs and outputs of a digital circuit, you can write the entity. Okay. So similarly, you practice of writing entity declaration for the full adder. Okay, in full adder case, we have three inputs A, B, C in, two outputs sum and carry. So you develop the entity declaration for this. Otherwise, we will discuss in the next class. Okay. Then coming to architecture body. Okay, this is another entity declaration. Coming to architecture, so let us see first of all the syntax for the architecture also. Okay, so the syntax is it starts with the word architecture. It starts with the word architecture, followed by architecture name of entity name. So to which entity this architecture is related, so that the entity name you need to mention is, this is the first line. After that, declarations, different types of declarations you can place here. Example, signal declarations, constant declarations, functions, procedures, component declarations. Okay, different types of declarations are, whatever the declarations, those must be done before the word begin. It is immediately after the first line. Okay, then there is a word begin. So after begin only you can write the executable statements, but in the architecture case, the statements all are treated as the concurrent statements, that is simultaneously executed statements. Okay, so each and every statement can end with the semicolon again. And finally, end architecture name. Like that you can consider the architecture syntax. Okay, and if you take the example of same half adder, Okay, and again this okay, so before going to writing the architecture of same half adder, so let us see what are the different models are available or modeling styles are there for writing the architecture. In the language, usually you have 4 different models. Those are data flow model, behavioral model, structural model, and combination of these three. Combination of these three. Okay, so you can write the program in the data flow style, behavioral style, structural style, or using more than one style. That is called mixed style. Okay. Now let us take data flow model. How to write the architecture body for the data flow model, and for same digital circuit, that is half adder. But for writing the architecture body, developing the architecture body, the internal information we have to know. Internal information is, say, logic circuit or Boolean expression data or truth table data, like that. Okay. So here, based on the Boolean equations, usually the data flow style of the programming is used if you know the Boolean expressions in general. Okay. So what is the Boolean expression for sum is A XOR B, whereas for carry A and B, right? A and B. Now let us declare first of all the entity declaration for this half adder. Okay, so after that, already in previous class we defined it. Not previous class, in the same class we have seen the entity declaration for the half adder. Now coming to architecture body, the architecture body is, what is the syntax? The syntax of architecture is architecture. The word architecture, I am giving the name just df of entity name, that is half adder is. Here no declarations, that's why directly I have written begin. So begin, after begin, the statements are in the data flow style. The statements like Boolean equations. The statement is similar to Boolean equation, that is sum less than equal A XOR B. Similarly, another statement is for carry less than equal A and B. Finally, end with the architecture name. Okay, so this is the data flow style of programming in VHDL. Here the statements are, the concurrent statements are known as the signal assignment statements. Signal assignment statements. Their appearance is similar to Boolean equation. Similar to Boolean equation. Okay. This is about the representation of entity and architecture, that to architecture in the data flow style. Similarly, you can take the exercise of writing the data flow style of architecture for the full adder. Okay, let us take only full adder in this class. Okay, and in the next class we can go for the another way of representation of architecture styles, right? Thank you.